In this lesson, we're going to consider z-scores and percentiles. So for our first definition here, a z-score is the number of standard deviations that a given value x, taken from a data set, is above or below the mean of that data set. So it's calculated using either the sample or population statistics. So here's how we calculate it. So if we're given a score x, then we simply calculate the z-score for that score x by evaluating x minus the mean divided by the standard deviation. And what this tells us is this tells us how many standard deviations x is away from the mean. For example, if you take a score x, let's say x is the score 10, and let's say the mean is 2, and let's say the standard deviation is 4. Then how many standard deviations is 10 away from the mean mu? Well, 10 minus 2 is 8. And 8 is 2 of the 4's here. So the score x would be 2 standard deviations away from 4. Or we would calculate that by evaluating 10 minus 2 divided by 4, and that gives us 2 back. So this is how many standard deviations 10 is away from the mean, which is 2. Now this 2 and this 2 are unrelated in this case. Now you can also use sample statistics to calculate z-scores in case you don't have the population, mean, and standard deviation at hand. So you can just evaluate x minus the sample mean divided by your sample standard deviation. And that's how we calculate a z-score. And once again, you should think of it as determining the number of standard deviations that a score x is away from the mean. Alright, now let's consider some uses for z-scores. So z-scores, as we said, measure the number of standard deviations a score is above or below the mean. And they can be used to compare scores from two different data sets. That's one way to use z-scores. So as we'll see in the next example, if we have two different, let's say we have two different classes, an English class and a math class, and we have test scores from each class. And say we have two people who scored 85 in our one class and 85 in another class. We may want to know which person did better relative to their particular class. Well, we could use a z-score to do that, as we'll see. Also, a score x is often described as being unusual if it is more than 2 standard deviations away from its mean. And so if we were to calculate the z-score, that's the same as saying the z-score is less than -2 or greater than -2, greater than +2, sorry. So if the z-score is less than -2 or greater than +2, then that means the score x is more than 2 standard deviations away from the mean, and we would say the score x then is an unusual score. Now let's take a look at an example. So here, as we mentioned earlier, we have 2 classes and test scores from each class. Now let's calculate the z-score for the scores of 85 from each class. And then we'll ask ourselves which student performed better on the exam relative to the rest of the class. So for class 1 and class 2, we need to calculate the mean and the standard deviation. So let's do that using Excel, or you can use a calculator also. So here we have our 2 scores, our sets of scores for each class. And so down here for class 1 and 2, we have to calculate the mean and the standard deviation. So we'll do the mean for this class. So that comes out to be a 79.1. And then we'll just copy that over. And the mean for our other class is 76.5. Now we also have to calculate the standard deviation, so we'll use the stdev function, and we want to use the stdev dot s for a sample. And there's our standard deviation for class 1. And let's just copy that over here, and that'll give us our standard deviation for class 2. Now let's calculate the z-score for the score of 85. So what that's going to be is that's just going to be, I'll just write it out here for you. So for the first score of an 85 from class 1, for class 1, the z-score will be 85 minus our mean, which is 79.1 in this case, divided by our standard deviation, which is 12 point, we'll say that's 12.30. We'll round it to 2 decimal places. And for class 2, our z-score is 85 minus 76.5 divided by 11.75. Alright, and now we just need to calculate these two. And when we do that, for the first z-score, we're going to get, we get 0.48. And for class 2, we get 0.72. So in other words, the 85 in class 2, that person, their score was 0.72 standard deviations above the mean. And in class 1, the person who got an 85, their score was 0.48 standard deviations above the mean. So since this is the higher z-score, we could interpret that as meaning that the person in class 2, their 85 was a little better relative to the rest of the class than the person who got an 85 in class 1. So the higher z-score here represents the better test score. Now let's take a look at percentiles. So here's our definition for percentiles. Percentiles are measures of location denoted by numbers P1, P2, all the way up to P99 that divide a data set into 100 groups with about 1% of the scores in each group. So for example, if we were to calculate P25, well, that score for that particular number, once we find out how to calculate it, about 25% of your data will be below that number, and 75% of all the scores will be above that particular number. So that's what P25 would represent. P50, about 50% of all the scores would be below that number, and 50% of all the scores would be above that number. Well, that would also be our median. That's actually the exact same thing as our median. And P75 would be similar. For P75, 75% of your scores would be below that number, and 25% would be above that number. So percentiles give us a way of comparing a data value to the rest of the data set, much in the way z-scores did, and in addition, they can give us an understanding of the dispersion of a data set by constructing box plots. Now there's two ways we can evaluate percentiles. So first of all, if we're given a particular score X from the data set, then we can calculate the percentile of the score X relative to the rest of the data. So by doing that, if we calculate the percentile for that score X, that'll tell us about what percent of data is below that number, and then correspondingly we can also evaluate what percent of data would be above that number. We can also do this. If we're given a desired percentile that we want, for example the 25th, we want to know what score corresponds to the 25th percentile, okay? Then we can find the number pk in the data set corresponding to that desired percentile. So there's two things we can do when calculating percentiles. Once again, we can be given a score X and then calculate what percentile score X corresponds to, or we can say, all right, we want to know the score corresponding to a certain percentile K. So let's take a look at the first type. So the percentile of a score X, if we're given a score X, it is defined to be the percent of scores lower than that particular score X, and is calculated like this. So the percentile of score X is simply the number of scores less than X. So you just have to count how many there are in the data set that are less than X. And then you divide by the total number of scores in your data set, and then multiply by 100%. And that'll give you the percentile for score X. Many of you may recognize something like that, like from the SATs or SATs. Maybe if you took your SATs and you were told that you were in the, say, the 65th percentile. Well, what that means is approximately 65% of all the people who took the SATs on that set of exams on that day scored less than you did. So that's what it means to be in the 65th percentile. About 65% of all the scores were less than your score. So for example, if we're given this set of scores from our class example, 85, 65, and so on, let's calculate the percentile of the score 85. Alright, so all we have to do is count up how many scores are less than 85, divide by the total number of scores, multiply by 100, and that's it. So let's see. We have a 65, so that's 1, 2, 3, 4, 5. So we have 5 scores less than 85. And so it's going to be 5 divided by, and what's our total number of scores? We should have 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 scores divided by 10 times 100%. And of course, that is equal to 50%. Right, 5 over 10, 0.5 times 100, and then so you have 0.5 times 100, move the decimal place 1, 2 over, 50%. So that's the percentile for the score of 85. Now keep in mind, if you had another score in here of 85, you would not count that score as being less than 85. That's equal to 85. So any other 85s in here, you would not count them in the number of scores less than 85. It has to be strictly less than 85 to be counted in here. Alright, now let's take a look at this. Now let's take a look at calculating percentiles for a given percent that we would like to, that we're given. So if we're given a percent K, for example the 25th percent, the kth percentile, pk, that's what we want to try to find out. So we want to find a score corresponding to the 25th percentile. That represents the value in which approximately k% of the data values are less than pk, and 1 minus, oops, that should be a k right there. 100 minus k% of the data values are greater than pk. So in other words, once again, you have your score pk, and k% of all of the data values will be less than this particular number, and 100 minus k% will be greater than that number. So we're trying to find that number now. So we're not given the score x. We want to find the score corresponding to the kth percentile now. All right, just a few definitions here before we actually look at how to do that. So first of all, for quartiles, the 25th percentile is also known as Q1. That's called your first quartile. That's a very important concept, as we'll see later when we deal with box plots. The 50th percentile is called Q2. That's also the median that we evaluated earlier. And the 75th percentile is called Q3, or our third quartile. We can also have deciles. We don't use them very often, but P10 would be your first decile, P20 your second, P30 your third decile, and so on. Although we're not going to really use them here. And also take note once again that the median of the data set is merely P50 or Q2. They're the exact same number. Now here's how we calculate pK. So the first thing we need to do to calculate pK is to order the data set from low to high. That's very important. Then we have to calculate this number LK, and that is simply n plus 1 times k over 100, where n is the number of scores in your data set. Now we have two cases. Either the LK can be a whole number, or it can have a fractional part to it. If LK is a whole number, that's easy. So for example, if LK comes out to be 3, then pK would just be your third value in your data set from low to high, counting from low to high. So in other words, pK would just be, in this case, it would be x3 if LK came out to be 3. So if k is a whole number, it's very easy. pK would just be xLk. That's if k is a whole number. Now, if the LK is not a whole number, then we have to do a little bit of work. So, for example, suppose that the LK came out to be, let's say it came out to be 3.4, let's say. Well then, pK would be 40% of the way between the third and fourth data score. Or in other words, let me say it like this. pK would be your third data score plus, now, plus 40% of the way towards the fourth data score. So in other words, we would, if we evaluate this quantity, x4 minus x3, and then we would multiply that by 40.4 to get 40% of the way. So this value here would represent 40% of the way between the third and fourth data score. Perhaps to see that a little better, if we do a graph down here, suppose that x3 is right here and x4 is right there. Then if LK came out to be 3.4, pK would be 40% of the way between x3 and x4. So that would be pK. Now the way we get that number once again is we go up to x3. So we take x3 and then we add 40% of that distance. And this distance is x4 minus x3. And then we multiply that by 0.4. So that's how we would get 40% of the way between x3 and x4. So we would just do this up here. And that's what we have written down here, just in a general format. But you might find it a little easier just to think of this example. Now let's take a look at an example where we calculate some percentiles. So here we have our trusty bear weight data set, and what we're going to do is we're going to look at the length of the bears, that column, and we're going to calculate Q1, Q2, and Q3, the first, second, and third quartiles, or P25, P50, and P75. So now the first thing we want to do is sort the data set by the lengths. So what we'll do here is we'll just highlight everything, select filter, and then we can click on this little tab here and sort the lengths from smallest to largest. There we go. Now for Q1, we first of all remember that that's equal to P25, so we need to calculate this L25. Now we have 54 rows of data, so the N is 54 plus 1, and then we multiply that by 0.25, or 25 over 100. And when we do that, we get 13.75. So Q1, or P25, is going to be 75% of the way between the 13th and 14th score in our set, sorted from low to high. So let's find those two values. So if we scroll down here, let's see, the 13th and 14th data value are going to be in these two rows. Remember, we have a header row, so it's actually going to be 14 and 15. And so going over here, we see that we're going to be looking at these two scores right here. So Q1 is going to be 49 plus 75% of the distance between 49 and 50. Or if we look at 50 minus 49 times 0.75, of course this is just 0.75, we get 49.75, and that is Q1. That represents our 25th percentile. So about 25% of all the bears had lengths less than 49.75, and 75% of all the bears had lengths greater than that number, approximately. Now Q2, all right, that is P50. So L50, we have to calculate that first. So that's going to be 54 plus 1, that's just going to be 55, times 0.5, or 50 over 100. And that is going to be 27.5. So Q2, which is also our median, is going to be halfway between the 27th and 28th score. So we have to scroll down here to find those. And right here they are. So it's actually the 28th and 29th row. And going over here, we are looking at these two numbers, so 60.5 and 61. Okay, so Q2 is going to be 60.5 plus, and then we have to go halfway between here. So that's going to be 61 minus 60.5 times 0.5. And of course, you could probably realize that the number right in between these, or the midpoint of these two numbers, is going to be 60.75, and that's what this comes out to be if you evaluate it. 60.75. So that's actually your median. Okay, that's just halfway between these two numbers. You can just add these two and divide by 2. That's a quicker way to do it. Now for Q3, that is going to be P75. Now we first need to calculate this, our L. So L75. So that's going to be 55 times 0.75. And that comes out to be 41.25. And so Q3 is going to be 25% of the way between the 41st and 42nd score. So let's find those two scores. So those are going to be right here. Actually going to be the 42nd and 43rd row. And so if we go over here, we're going to be looking at these two values right here. So 25% of the way between those two numbers. So it's going to be 66.5 plus, and then the difference, 25% of the difference between these two numbers. So 67 minus 66.5 times 0.25. And we get 66.625, which it would be okay if we rounded that to 66.63 if we wanted. We're rounding one more place than what our data is given to us. All right, and so there we go. We have our Q1. Let's see, Q1 was right here. Q2 and Q3. Now let me show you how to do these using Excel. We can also use Excel to evaluate these. Give myself some room up here. Okay, so to evaluate Q1 or the 25th percentile, we can use this Excel function. So watch this. It's called percentile. Now there's two types of percentiles. There's percentile.exc and percentile.inc. We want to use the exc one. So percentile.exc. Now we have to highlight the array of numbers that we want. So we were doing the lengths, so we highlight all of these numbers. And then we go comma. Now we want the 25th percentile first, which is Q1. So comma 0.25. And then hit enter. And there we go. We get 49.75, which is exactly what we found. Then if we want, we could go back up and change that number. Let me just erase this right here. If we wanted the 50th percentile, we could change the 0.25. Let's just do it down here. We'll do a new one. Now we want our array. We could actually just highlight the entire column like that. Excel knows that the first one is a header, and so it doesn't do anything with that. Comma 0.5. And there we go, 60.75. And then for the final one, our array are the lengths, comma 0.75. And there we go, 66.625. So that's exactly what we found. And that's how you can do it with Excel. Now, if you use another software program or maybe a calculator like the TI-83, oftentimes you will not get these exact numbers. I found that calculators and computers will sometimes use different techniques for finding these percentiles. You'll get numbers that are very close to them, but they might be off a little bit. So just to warn you about that. If you're doing the problems on web work, this is how you should do the problems on web work. So you can actually use Excel to check your answers when you're doing them with web work. And this is the way you would do them for the web work problems. Alright, so that concludes our discussion about percentiles.